Picture this: you pull into a charging station, plug in your electric car, head inside for a quick coffee, and by the time you've taken your last sip, your car is 80% charged and ready to go. 10 minutes. That's it. No more planning long trips around charging stops. No more sitting around for hours waiting for your F to juice up. No more range anxiety. Welcome to the future of electric vehicles powered by solid-state batteries. In this video, we're diving deep into what makes this technology such a game changer, how it works, the companies leading the race, and what it means for the end of the gas era as we know it. Stick around till the end, because once you understand what's coming, you'll see why this single innovation could reshape transportation, energy, and even geopolitics. Let's be honest. Electric vehicles have come a long way. They're faster, quieter, and cleaner than ever before. But there's always been one big problem with charging. Yes, EVs save you from gas prices and emissions, but long charging times still make a lot of drivers hesitant. You see, traditional lithium-ion batteries, the kind used in most electric cars today, have limits. They take time to charge, they degrade over time, and they can overheat if pushed too hard. So even though EVs promise a sustainable future, charging them still feels a little like waiting for dial-up internet in the age of 5. That's where solid-state batteries come in, and they're about to change everything. What exactly is a solid-state battery? Let's break it down. Every battery, whether in your phone or your car, has three main parts: an anode, a cathode, and an electrolyte that carries the charge between them. In today's lithium-ion batteries, that electrolyte is a liquid or a gel. It does the job, but it's also the weak link. Liquids can leak, overheat, or even catch fire under extreme conditions. Now, solid-state batteries replace that liquid with, you guessed it, a solid electrolyte. And that one change transforms the entire performance of the battery. A solid electrolyte allows for faster ion movement, higher energy density, and dramatically improved safety. That means batteries that last longer, charge faster, and don't risk bursting into flames. In other words, it's the difference between an early flip phone and a modern smartphone. Same concept, completely different universe of performance. So, how fast are we talking? Several automakers, including Toyota and QuantumScape, have unveiled first-generation solid-state batteries capable of charging from 0 to 80% in under 10 minutes. Let that sink in. That's faster than filling a tank of gas. The key lies in how ions move through the solid electrolyte. With less internal resistance and better thermal control, solid-state batteries can handle extremely high charging currents without degrading or overheating. To put it simply, more power goes in faster and safer. And this doesn't just reduce charging times, it opens the door to smaller, lighter batteries that deliver even more range. Some early tests show vehicles running up to 1,000 kilometers, or around 620 miles, on a single charge. That's from Los Angeles to San Francisco and back without recharging. If you've ever driven an electric car, you've probably felt that subtle fear, wondering if you'll make it to your next charging stop. That's range anxiety. It's one of the biggest psychological barriers to EV adoption. But once solid-state batteries become mainstream, that fear disappears. Here's why: you get longer range, faster charging, and better durability. In fact, early lab tests suggest solid-state batteries could last up to 1,000,000 kilometers of driving. That's the equivalent of driving your car for 15 years without ever needing to replace the battery pack. It's the holy grail of electric mobility: long-lasting, fast charging, and reliable power. Now let's talk safety. Lithium-ion batteries are efficient but can be volatile. Remember those viral videos of EVs or phones catching fire? That happens when liquid electrolytes react with oxygen during overheating or damage. Solid-state batteries eliminate that risk entirely. Because there's no flammable liquid, there's virtually zero chance of thermal runaway, the chain reaction that causes battery fires. That means safer EVs for consumers, safer transport of batteries, and lower insurance costs for manufacturers and drivers alike. This safety factor alone could be the reason regulators and automakers push solid-state adoption faster than anyone expects. So, who's building the battery of the future? Several big names are in a global race to dominate this technology. Toyota has been quietly leading the charge, announcing a prototype with a 1,200 km range and 10-minute charge times. QuantumScape, a U.S. company backed by Volkswagen and Bill Gates, is developing a ceramic electrolyte for ultra-fast charging. Samsung and Hyundai are investing billions, combining EV and smartphone research to achieve breakthroughs. And in China, giants like CATL and BYD are focused on scaling and affordability. This isn't just a competition for better cars, it's a battle for global energy dominance. Now let's talk money, because innovation doesn't matter if it's not scalable. Right now, solid-state batteries are expensive to produce. But this is how every technology starts. Remember when flat-screen TVs cost $10,000? As demand grows and companies scale production, costs fall dramatically. Experts predict that by 2030, solid-state batteries could be cheaper per kilowatt-hour than today's lithium-ion packs, making EVs more affordable than gasoline cars. Plus, solid-state batteries are greener. They use less toxic materials, produce fewer emissions, and are easier to recycle. While most headlines focus on electric vehicles, the implications of solid-state batteries go far beyond cars. Think about it: smartphones that charge fully into minutes, drones that fly for hours, laptops that last for days. It could even power electric planes and ships. It's a leap that could redefine how energy is stored and used across every industry. So, could this really mean the end of gas stations? The short answer: yes, eventually. Once EVs can charge in 10 minutes and drive 1,000 kilometers, the need for traditional fueling infrastructure drops dramatically. We'll likely see charging stations evolve into energy hubs, places where you can charge, rest, shop, and connect. To be clear, there are still technical hurdles. Manufacturing at scale is tricky, and some solid electrolytes are sensitive to cold temperatures. But every major battery innovation faced similar challenges. With billions in research funding pouring in, these problems are shrinking fast. So, what does this mean for you? It means your next car might not just be electric. It might be ultra-fast charging, ultra-efficient, and practically maintenance-free. You'll be able to drive farther, spend less time at chargers, and never worry about your battery degrading prematurely. Let's zoom out for a moment. The shift to solid-state batteries will ripple far beyond the auto industry. If electric mobility becomes the global norm, demand for crude oil could plummet. That changes global trade and energy politics. Countries leading in battery manufacturing like Japan, South Korea, China, and the US could gain massive economic and strategic advantages. The new oil is electricity, and whoever controls energy storage will shape the future. So, when can you buy one? Realistically, you'll see early commercial launches in premium EVs around 2026 to 2027. Wider rollout to mid-range models should happen by 2030, and from there, solid-state could become the global standard. The prototypes are real. The factories are being built right now. 10-minute charging isn't just a technical milestone, it's a psychological one. It changes the way we see electric vehicles, not as limited, but as limitless. And that shift in mindset is what truly fuels revolutions. The future is here, and it's faster, safer, greener, and smarter than anything we've had before. So, what do you think? Would you switch to an EV that charges in 10 minutes? And do you think this really means the end of gas stations as we know them? Drop your thoughts in the comments. I love reading your perspectives. If you enjoyed this, don't forget to like, subscribe, and hit that bell icon so you never miss a peek into the future of tech. Thanks for watching, and as always, I'll see you in the future.